need to do is find the total resistance. And if we look over here, we've got one resistor there and two in series. So we'll add the series resistors first. So that's going to be straightforward. We can replace that with a 6. So we've got 4 ohms plus 2 ohms equals 6 ohms. That gives us a 6 ohm resistor in parallel with a 6 ohm resistor. We can use the 1 over RT equation, but one of the shortcuts you'll know is that when you've got two resistors of the same value in parallel, the total resistance just halved, because it's 1 over 6 plus 1 over 6, which is 2 6, and if you flip that over, that's 6 divided by 2, which is 3. So we can replace all of those resistors quite straightforward with one resistance, or the total resistance as we'll call it, which will have a value of just 3 ohms. So that's our resistance total done. Okay, so now that we've got a simplified circuit of just one resistor with a EMF of 3 volts and a resistance of 3 ohms, of course then we can work out what I1 is going to be, which is there, and I1 of course is going to be equal to just our Ohm's law, which will equal V over R, which is 3 divided by 3. So that tells me that I1 is equal to 1 amp. So we know RT now, and we know that I1 is 1 amp, which of course means that I2 is going to be the same, because it's just a series circuit. Remember, we simplified the circuit down to just having one cell and one resistor, and as it's a series circuit, I2 will be the same as I1, so that will also be 1 amp. Okay, so we know RT, which we said was 3 ohms. We know R1 and R2 now, which we've got 1 amp for both. So now we can start thinking about V1. Now V1 is the voltage there, and as it's a parallel circuit, if we think about the current flowing around there, any charge carriers that will travel through that resistor will only go through that one resistor, so they will lose all their electromotive force, EMF, through that one resistor, which means that we can then say that V1 will be equal to the EMF, so V1 is going to be 3 volts. Okay, so now we know what V1 is, which we've said is 3 volts, we can now think about I3, because of course, if we've got 3 volts there, and we've got 3 volts there, we've now got a resistance of 6. So then we can use our Ohm's law. Remember, it's V equals IR, and all rearranged. So in this case, I is equal to V over R. V is, of course, going to be 3 volts, and R is, of course, the 6 ohms. So the current will be 0.5 amps. Okay, so we know that RT was 3 ohms. We know that I1 and I2 were both 1 amp. We know that V1 had to be 3 volts, and then that led us to I3 being 0.5 amps. For I4, which is that one, we can use Kirchhoff's first law about current. So we know that in there we've got 1 amp, and if we've got 0.5 amp going here, that means that the current going this way will have to equal 0.5 amps, because of course I4 plus I3 have to equal I1. So that means we now know what I4 is, 0.5 amps. So we've just got to work out those final two voltages. Let me just tidy this up. So in this case, we now know that I4 is equal to 0.5 amps. And so to work out V2 and V3, we're now going to take our V equals IR equation and put those resistances with that current. So V2 will of course be the current, 0.5 amps, multiplied by the resistor, which just under there is 4 ohms, which of course will give me 2 volts. That's that one done. For this one, same situation. Now I've got the current, 0.5 amps, and this time I've got 2 ohms, so I'll multiply that by 2 ohms, which of course will give me 1 volt. So that's it all done. I'm just going to double check by just quickly removing all this mess and make sure that I can now fill in all these. So we've got, bear with me, so we've got here RT was our 3 ohms, R1 and R2 was 1 amp, V1 was 3 volts, and I3 was 0.5 amps, and I4 was 0.5, and finally V2 we said was 2 volts, and V3 we said is 1 volt. And just checking very quickly, got 3 volts of EMF, we've got the charges that travel through that one, only travel through one, so that's why we said here the potential difference was 3. And then let's pick a blue so it's easier. We've got some, oh blue I said, there we go, we've got some that are travelling that way, and the ones that travel that way of course have 3 volts of EMF, and they travel through 2 different resistors. We said there we've got 2, there we've got 1, and Kirchhoff's second law about the potential differences having to all add up correctly gives us V2, which we said was 2, V3, which we said is 1, adding up to that. So it all adds up. So just to recap, to work it all out, this guided our way. We first went through finding the total resistance. Once we found that, then we could work out the current coming out of the cell. And that current, of course, was going to be determined by that equation. Once we've got that equation set, we know what the current is. We can then look to use Kirchhoff's second law to see if we can find any potential differences in the circuit, because we've got that. So then we can use that equation to find any potential differences, and then that's it. That's all we have to do. I hope that makes sense. Thank you.